Hey guys, and welcome back to another video on the channel. In today's video we're going to be covering the Mathematical Methods multiple choice booklet for the external exam of 2023, paper 1, and this is for the QCAA syllabus in Australia. Okay, so this paper you're not allowed pretty much a graphics calculator, it's all going to be done by hand, but you are able to pretty much have a formula sheet provided by the QCAA syllabus, and yeah, that's about it pretty much. Yeah, let's get straight into the questions pretty much. So, question 1. E to the natural log of x is equivalent to. So this one is just a basic rule pretty much. So if you have e to the log of 2, these terms here, the e and the Euler are inverses of each other, and because they're to the power they effectively cancel out, so you just get 2. So e to the log of any number up here would just be whatever that number is inside the logarithmic term here pretty much, okay? So in this question here, when we have e to the natural log of x, the correct answer would be x. So the correct answer in this question here would be C. Okay. Yeah, let's take a look at the next question. So question 2, if f of x is e to the 6 minus 2x, determine the value of f dash of x at x equals 2. Okay. So what this is asking for is what is the gradient at x equals 2, because f dash of x is another symbol for dy dx. And when they have f dash of 2, that is another symbol for dy dx at a particular x value, so x equals 2 pretty much, okay? So first of all, we need to work out what f dash of x is, so we have to differentiate, okay? Now we can see straight away it's an Euler term, so we know how to differentiate an Euler function. It's just itself pretty much. So this would just remain the same. However, we have an inside function we can see up here in its corresponding power pretty much, okay? So what we have to do is pretty much a chain rule. So you have to differentiate the inside function and differentiate the outside. So f of x is e to the 6 minus 2x. So f dash of x would be differentiate the inside first. So the differential of this function here would just be minus 2. So you have minus 2 and then multiply it by this, and it will just be this because the differential of either x is still itself. So it's just e to the 6 minus 2x, okay? So then you have to work out f dash when you put in x equals 2. So just substitute x for 2. So go for 2 here, negative 2, e to the 6 minus 2 times by 2. So what we'll get is f dash of 2 is negative 2 e to the squared pretty much, okay? So you can see straight away the correct answer would be D in this question here, okay? Now, let's take a look at the next question. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it, okay? So question 3, a bag contains 10 buttons the same shape and size in different colors. So 5 blue, 3 green, and 2 red. If 3 buttons are randomly drawn from a bag, which probability can be calculated using a binomial distribution? So with a binomial distribution, the probability needs to remain the same. So regardless of which color you pick, you need to pretty much use replacement, okay? So these examples here without replacement and without replacement cannot be used at all, because that probability, the sample size changes, and it changes all the probabilities of drawing out a ball pretty much, okay? Now, it has to be the same thing as well pretty much, okay? So pretty much we take a look here, we can only draw 3 buttons of either blue or green because there's only 2 of red, okay? So the probability of 3 with replacement and the probability of 3 blues with replacement would be correct answers, okay? But we can see we only have one of them here pretty much. This one is incorrect because it's 2 different objects and the probability is different, okay? So remember, with a binomial probability, the probability of drawing a certain object needs to remain the same. So when you're changing the objects, you're hence changing the probability even if you had replacement pretty much, because the probability of a green isn't the same as the probability of a red. So the correct answer would be A, okay? Let's take a look at the next question. So question 4. If the gradient of the function f of x is given by 20 over x cubed, then f of x is equal to. So when they're saying this is the gradient function, that means we know pretty much what dy dx is, okay? So gradient function is dy dx. So dy dx is 20 over x cubed, okay? If you rearrange this, dy dx is 20 times by x to the minus 3. To work out y, we have to integrate both sides. So hence we're integrating pretty much 20 x to the minus 3 dx, okay? Now this one is just a simple power rule. Add 1 to the power, divide by the new power, and add a constant. So it'll be 20 x to the minus 3 plus 1 divided by 3 plus 1, or negative 3 plus 1 plus a constant. So effectively we're going to have minus 4 divide, negative 2 divided by 20. So it's going to give you negative 10, and then you'd have x squared on the bottom plus c. So the correct answer we can see straight away is c. And that's about it, pretty much, okay? So a key term that gave that away was gradient function of f of x, okay? So a lot of people might have differentiated it because they had f of x, but it's all about the words they pretty much use there, okay? Let's take a look at question 5. So determine the integral from 1 to 3 of 1 over 2x dx, okay? So this one here, we know it's going to be a natural log, so what we can do straight away is take out the half out the front pretty much, okay? So we can take out that half. So we'll go the integral of 1 to 3 of 1 on 2 x dx is equal to 1 half integral of 1 on x dx. And then we have 1 on 3 as your bounds. This is going to be a natural log, so you have a half. We've got to have square brackets for the bounds. Natural log of x, 1 and 3. Then you substitute your bound, so you have a half multiplying natural log of 3 minus natural log of 1. So this gives you 1 half natural log of 3. Okay? And you can see straight away the correct answer is D. Okay? Let's take a look at the next question. So, substitution for h are used to estimate the limit of a to the power of h minus 1 on h as h goes to 0. Which sequence is the most appropriate? Okay, so straight away, if h is going to 0, that means it needs to be a decreasing pattern. Okay, so a decreasing pattern going, if it's a decreasing pattern, it's going from positive to 0, or it's an increasing pattern of negative to 0. So think of it on the number line is, if this is 0 in the moment, the decreasing pattern means we're over here and we're going this way, and the increasing pattern means we're over here and we're going this way. Okay, so this sequence here straight away is an explanation, well, an example of the increasing pattern. So you go from minus 4, negative 2, negative 1, negative half. You're getting closer and closer to 0 from this direction here. So that is a viable substitutions we can make. Okay, this one here, if we take a look, we're actually going from a negative small number, but we're actually going in the opposite direction. Our number is slowly getting smaller and smaller, so it's going away from 0. So this wouldn't be a viable option. This one here, we completely go through 0 and we don't even substitute it in. You go 2, 1, 0. You're just going pretty much starting here and you're going this way. That's not a limit for 0, so that wouldn't be correct. And this one here, we're going in the complete opposite direction. We're increasing and we're going away from 0, so that can't work either. So the correct answer would be A. Okay. Let's take a look at question 7 now. So, determine pretty much the mean of a continuous random variable x with a probability density function as follows. Okay, so the mean of a continuous random variable, otherwise known as mu, is the integral from negative infinity to infinity of x times by f of x, which is the probability density function. Now, these infinities represent the n bounds of your probability density function. So in our example here, mu would be the integral from 0 to 4 of x times by 1 on 8 x dx. Okay, so this is your general expression here, but the negatives, infinities, just represent the n bounds of pretty much your probability density function. Okay, right, so let's write this out just so we can have enough room for it. X times by 1 on 8 is x squared, and we can also take out the 8th, so we'll have 1 on 8, the integral of 0 to 4 x squared dx is mu. So mu is just the mean of the continuous random variable. Then we'll integrate this. So mu will be 1 on 8. The integral, actually we're going to integrate that now, we're not going to write it twice. We'll have x cubed on 3, 0 and 4. Substitute in 4 because the 0 is just going to disappear. So mu is going to be 1 on 8 times by 4 cubed on 3. 4 cubed, you can work that out because 4 squared times by 4, so you have 16 times by 4. So you're going to have 64, I believe. And then we also know 64 is the same as 8 times 8. So effectively on the top here, you have 1 on 8 times by 8 times by 8 on 3. And you can see one of the 8's cancel out. So the correct answer would be 8 on 3. Okay. So the correct answer is D straight away. And that's how you pretty much would do it without a calculator. Because remember, this test is a non-calculator test. So you have to do some of this stuff pretty quickly as well. Okay. Righto, so let's take a look at question 8. If you have any questions about question 7, leave something in the comments and I'll try my best to answer it, okay? So, the sample size n was used to calculate a population proportion. The approximation margin of error was 3%, calculating using a z-score of 1.6. Given the sample proportion was 0.6, determine n. Okay, so the formula for margin of error isn't on the formula sheet, but it's pretty much given by this. So margin of error is the z-score, in this case it's 1.6. Actually, I'll just write the general formula so you can see it. So margin of error for a sample proportion is the z-score square rooted of your sample proportion, so p of hat, 1 minus p of hat, all over n pretty much, okay? Now what we've been given in this question is we've been given this, and this, and this, and we've also actually been given this as well. So what you can put for margin of error is it's going to be 3%, so it'll be represented as 0.03. The z-score we know is 1.96, so 1.96. Then square root, and we can substitute that for 0.6, and 1 minus 0.6 all over n, okay? And we're pretty much going to work out what n pretty much is straight away. So, first of all, we probably want to work out what this is going to be, because that's not pretty much appearing in our answers pretty much at all, okay? So, straight away we know this 1 minus 0.6 is going to be 0.4, so 0.6 times by 0.4 would be 0. What would that be? 24, I believe. Or 0.24. Yeah, just off the top of my head, I think that would be it. Yeah, just double check. Sorry, never that good with arithmetic, even though I teach math. So you can substitute this guy in for the blue bit here pretty much. So you're going to have 0.03 equals 1.96 square root of 0.24 on n, and then you're going to pretty much solve for n. So 0. I forgot the 0. 0.03 on 1.96 equals the square root of 0.24 on n. You can square both sides to get rid of pretty much that square root. So you're going to get a following expression given like this. Then you're going to swap pretty much the n and this expression here. So this guy and this guy swap. So you're going to get n equals 0.24 over 0.03 on 1.96 all squared, and we can see that matches straight away with answer B. Okay. So you pretty much have to kind of remember one of these formulas here. Same with like the Z rule, where the Z score, where Z is your data point minus the mean over the standard deviation. So little ones like that you do have to remember for this test. But yeah, that's about it. Not a too hard question if you know the formula. But if you didn't know the formula, you probably wouldn't have got this, because you probably would have remembered it in different ways or not remembered it at all. Okay. Let's take a look at question 9 now. So, determine the integral from 0 to 3 of pi sine of pi on 3x dx. Okay, so this one, we pretty much want to do either a u substitution or something. So first of all, we just want to work out what this guy would be without any bounds. So you can see straight away we have an inside function in this integral. We have this guy here. So if you were to differentiate that, so this differential would just be pi on 3. So when you integrate that, you need to divide by this at the start. So you would pretty much have, actually we could just do it by hand. So you could go let u equal pi x on 3 du dx equals pi on 3. dx would be 3 on pi du. And you can pretty much substitute, let's use a different color. So this in that bit there, and this in that bit there. So effectively we'd get the integral of pi sine of u, 3 pi on 3 on pi du. You can see those pi's cancel out. So you're effectively integrating 3 sine of u du. So that would give you minus cos. So minus 3 cos of u. So that means pretty much this integral here, if I were to rub this out now because we've got a bit more room, and if you put the bounds in 0 to 3, would be minus 3 cos of pi x on 3 from, what was it, 0 to 3. Okay, so that's how you do that, doing a u substitution pretty much, but pretty much you've got to remember it as dividing by the inside differential, but that's the same as a u sub, but you're not really taught that in methods. If you have, you're very lucky, and you really taught that in specialists pretty much. Okay, so let's take a look at this bit now. So all we got to do is substitute in the bound, so substituting in the 3, and you want to substitute the 0 because cos of 0 is going to be 1. So we'll have minus 3 cos of pi on 3 times by 3 minus negative 3 cos of 0. This bit here, minus 3 cos of pi plus 3 cos of 0, so it's just 1. Cos of pi is minus 1, so that's minus 1. Negative 3 times minus 1 is 3, and then plus that 3 gives you 6. So the correct answer is B, which is 6. Okay. Righto, let's take a look at 10, the final question on this test. So the continuous random variable y has a probability density function given below. Determine the probability that's between 0 and a half. Okay, so this one's pretty easy. It's just the integral pretty much of this guy here. So 1 plus y dy from 0 to a half. Okay, so straight away just use the power rule. So add 1 to the power. So it's just going to be y plus y squared on 2. And then you're bound to 0 and a half. Substitute in just a half because the 0 is going to disappear. So you'll have a half plus a half all squared divided by 2. So you have a half plus, I think that would be an eighth because you have a quarter on the top divided by 2. And then we want to simplify it using fractions. So we have a half plus, actually we're going to change the half actually. So we have 4 on 8 plus 1 on 8. So all I did was change a half to 4 on 8, so they have common denominators, and that gives you 5 on 8. Okay, and you can see the correct answer would be C. Okay, and that's about it for this test pretty much. If you have any questions about the math methods paper here, leave something in the comments and I'll try my best to answer it, but I will see you in the next one.